এরপর বাংলা ক্লাস, তারপর কি ক্লাস?
তারপর হচ্ছে তোদের ইকোনমিক্স।
দুটো ইকোনমিক্স, তারপর এখন আমার সব কয়টা ক্লাস আছে, আমার শান্তি নেই।
So here we are getting the notes on nuclear atom. As Ziba was saying that this topic is really small one, and we could start with 26, topic 26, but according to my analysis, it's better to start with this one because it's giving you the basic knowledge of atoms and atomic structure, which will help you to understand some of the things in topic 26. That's why I'm bringing this one first, 27. So can anyone, Aisha, can you read the learning outcomes?
Learning outcomes. Candidates should be able to describe the structure of the atom in terms of nucleus and electrons. Describe how the Geiger-Marsden alpha particle scattering experiment provides evidence for the nuclear atom. Describe the composition of the nucleus in terms of protons and neutrons. Define the term proton number, atomic number, Z, and nuclear number, mass number. Explain the term
Nuclide.
Explain the term nuclide and use the nuclide notation AZX to construct equations where radioactive decay leads to changes in the composition of the nucleus. Define the term isotope. Explain using nuclide notation how one element may have a number of isotopes.
Okay, thank you. Livan, welcome back. Hello, Livan. Livan joined, just now he joined. Here we have 5 participants, you can check. Yeah. Livan, thank you for joining. And we missed you in first lesson. We discussed the exam paper in first lesson. So here we got nucleus, the atom, structure of the atom in terms of nucleus and electrons. So in nucleus we have neutrons and protons, you know that, right? Hello?
Yep.
Yes, sir.
So neutrons are neutral, they don't have any charge, and protons, they have positive charges. Electrons, they have negative charges. And if you think about the mass, proton and neutron, they are almost very equal, we can say equal or similar mass, but the electrons, they are very lighter element in comparison to protons. We will look upon it, the information are given below. Then we have one experiment discussion here that is called alpha particle scattering experiment. Geiger and Marsden, 2 scientists, they together did this experiment to understand the structure of atom and the property of nucleus using the gold foil. And we have already discussed C. Then we have the symbols for proton number, that is Z, and nucleon number, that means the combination of protons and neutrons, that is also known as nucleon number. Combination of proton number, or you can say after adding number of neutrons and protons, the number we get, that one is called mass number or nucleon number, and we express it with A, capital A. Then explain the term nuclide. Nuclide means the way we can represent a nucleus. You see here X, that is the symbol of any element, that one will be represented by X. and A will show you the mass number, and Z will show you the atomic number. Atomic number means proton number. To construct equations where with this notation we can understand how many protons are there, how many neutrons are there, and nucleon number is easy to understand. Also, if they are saying you that the, the atom is neutral, you can also get the number of electrons. How you can ask me how we can understand number of electrons? Neutral means positive charges and negative charges are equal, right? Hello.
Yes, sir.
Yeah.
Yes.
If any place or any question they are saying you that the atom is neutral, that means charges are available there are equal. That's why it is neutral. If charges are equal, that means same number of electrons and same number of protons are there, because proton has positive charges and electron they have negative charges, but the amount of charge is same. That is 1.19 into 1.16 into 10 to the power minus 19 coulomb. Okay, so this way we are getting the charges. We will have some more discussions on that. Look here, we have here isotopes. Can anyone tell me what is called isotope? Isotope
Elements
means,
with the same number of neutrons but same number of protons but different number of neutrons.
yes, they have same number of protons, but different number of neutrons. They are called isotopes. Can you give example of isotopes?
11H, 21H.
Yeah, one is hydrogen one, then deuterium, then tritium, right? We have three isotopes for hydrogen, and similarly we have for carbon. We have carbon 14, carbon 12 isotopes. We have uranium isotopes. So we will have more discussion here below. Here we have the amount of mass available in the neutrons, then protons. Can Moshi read it? Moshi, atomic model, this part.
এক সেকেন্ড স্যার, আমার ওয়াইফাই বাজে, আপনার এখানে ব্লার হয়ে গিয়েছে স্যার, একটু টাইম দেন স্যার,
Okay,
আমি অনেক
okay,
ঝাপসা ঝাপসা দেখছি।
okay. Will you take time or we can go to other student?
আচ্ছা স্যার, দাঁড়ান। অ্যাটমিক মডেল, রাইট স্যার?
Yes, yes.
The basic structure of an atom includes a tiny, relatively massive nucleus containing at least one proton and usually one or more neutrons. Outside of the nucleus are energy level, also called shells, which contain one or more electrons. The neutrons have the greatest mass, 1.6749 to 10 to the power minus 27 kg, and have no charge. The protons have slightly less mass, 1.6726 into 10 to the power minus 27 kg, than the neutrons and are positively charged. The electrons have very small mass, 9.1 into 10 to the power minus 31 kg, and are negatively charged. The electrons move around the nucleus is energy levels. The Bohr model, similar to the structure of solar model of the atom, is the easier way to indicate the location of the different parts of an atom.
Okay, so we have here Bohr atomic model. And
মারে কার ফোন?
this is quite similar to the structure of the solar system. We have here in the center we have the nucleus, and surrounding the nucleus we have electrons, like the planets. We are considering nucleus as the sun, in the solar system, and the electrons as the planets. We have here one atom, lithium atom, and lithium atom, you see there are 3 electrons, 3 protons, and 4 neutrons. Okay, so anyone tell me what is the mass number of lithium?
Yes, sir. আরেকবার বলবেন শুনি নাই।
What is the mass number of lithium? From this structure, you can understand the mass number,
3.
right?
What is it? 7.
7. The mass number has another name. Can you tell me the name?
Proton plus nucleon, neutral.
Nucleon
Nucleon
number.
numbers.
Nucleon number. So we will use both these terms. Nucleon number, sometimes we use mass number, and it is represented by A, right? Capital A. Okay. And what is the atomic number here?
3.
3. Why 3?
Proton number is 3.
Proton number is 3. So in hydrogen 1, how many nucleons are there in hydrogen 1?
1 nucleon.
Yeah, 1 nucleon. So there is only 1 proton, right? There is no neutron even. In hydrogen 2,
1 proton,
1 proton and 1 neutron. That's why we are saying it hydrogen 2, the nucleon number is 2, right?
Wait,
And
hydrogen one is only 1 proton. Sorry, 1 neutron.
yeah, that one is deuterium, we call hydrogen 2. 1 proton, 1 neutron.
No, I'm talking about hydrogen 1.
Yeah, hydrogen 1, there is no neutron, only 1 proton. In its nucleus, there is only proton. No neutron is available in its nucleus. Clear?
And electrons?
Electrons 1, it is, you see, proton is there, only 1 proton, positive.
Alright, so the proton and electrons are the same number. but
Yeah,
neutrons are
normally if it is neutral atom, it is not charged, it's not ion, then always number of protons, number of electrons are equal. That one we call as neutral atom. What we call? Can you say what we call that one? Neutral. If the number of electrons and protons are equal, we call it
Neutral atom.
neutral atom. Neutral. So when you will get some questions, if it is mentioned the neutral atom, from that information you can understand, yes, number of electrons are same as number of protons. Or they will give you number of electrons, you can understand number of protons from there. Okay, now Liban is there. Liban. Hello, Liban. Liban. Liban is silent. Hey, Liban. Liban. Liban is not talking. He's silent. Okay, so Ziba, you can please continue. The alpha particle scattering is experiment.
স্যার 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 স্যার
Yes.
লিবান আস করতে বলছে, ওর মাইক নাই।
Okay, fine. Then
Should I start reading?
yeah, please continue with this one, Ziba.
The alpha particle scattering experiment. Rutherford, along with his assistants H. Geiger and E.
Geiger.
Marsden,
Yeah.
Marsden started performing experiments to study the structure of an atom. In 1911, they performed the alpha particle scattering experiment, which led to the birth of the nuclear model of an atom, a major step towards how we see the atom today. They took a thin gold foil having a thickness of 2.1 into 10 to the power minus 7 meter and placed it in the center of a rotable detector made of zinc sulfide and a microscope. Then they directed a beam of 5.5 সেটা কি
Yeah,
NeV
5.5 mega electron volt. It is also unit of energy. Electron volt it is also one unit of energy. We will have this discussion later on. Okay, just you read it.
alpha particles emitted from a radioactive source at the foil. Lead bricks collimated these alpha particles as they passed through them. After hinting After hitting the foil, the scattering of these alpha particles could be studied by the brief flashes on the screen. Rutherford and his team expected to learn more about the structure of atoms from the results of this experiment. Should I
Okay,
continue with the
okay.
observation?
Look, whatever the experiment is done, we have some findings over there. Okay, here we mentioned it as observations or findings, you can say. So you continue these 3 points. These are very important. The most important thing of this, experiment. Please continue here.
Observations. Here is what they found. Number one, most of the alpha particles pass through the foil without suffering any collisions. Number two, around 0.14% of the incident alpha particles scattered by more than 1 degree. Number three, around 1 in 8,000 alpha particles deflected by more than 90 degrees. These
So
observations
here,
led to
here,
many
yeah, yeah. Here, these three observations, you please focus here. That first observation is the alpha particles we are passing through the foil. They are going without any interruption, right? Going straight. This is first finding. The second finding is some of the alpha particles, some of the alpha particles, they scattered by more than 1 degree. That means some are, repelled. When they are going closer to the nucleus, they are repelled. Then around 1 in 8,000 alpha particles deflected by more than 90 degrees. That means these are almost returning back. If it is more than 90 degree, that means they are almost returning back. So from these three observations, we will go for three conclusions later on. So you continue, please. Here, continue.
these observations led to many arguments and conclusions which laid down the structure of the nuclear model on an atom.
Yeah, the diagram is shown here. Look, the one we got here, the observations, those are also shown in the diagram. What they were saying, the first observation, this one. Uh, Here we only got four, only got four lines here. They show, or four alpha particles they show, but there are many. In this place, there are lots of, right? Only they showed four. That does not mean that only there is four. There are many, hundreds of thousands of alpha particles are there, which are going straight. Okay. Then those alpha particles which are closer, closer to the nucleus, you see they are feeling or they are experiencing uh, repulsion, okay, from the nucleus. That's why they are bending here, right? The more closer one, that's bending more. a little bit far one, that's bending a little bit less, and more far is bending least. This way it's happening. Okay, and the one which one is coming directly, it's returning back. Okay, it's returning back from the nucleus. So we will try to get conclusion from all these three observations. Again, I give the diagram here. The same thing in another way we are representing. You see here we showed uh, two nucleus. Here is one, here is another one. So how the in gold foil there is not only one atom, so there are so many atoms. That's why we are showing two nucleus, how the alpha particles are behaving in between two nucleus. Then okay, there is problem. Yeah, from here. Continue, Moshi.
Yes, sir, বলেন।
Yeah, continue from here, from this experiment.
ওই যে from the experiment থেকে।
Yes, yes, from there.
ওকে স্যার, তাহলে নাম্বার 1 থেকে শুরু করতেছি। Since most of the particles passed underweighted through the gold foil, the majority of the space occupied by the matter is vacuum, empty. As a few particles got divided in a
Deviated.
deviated
Deviated.
deviated through small angles, there must be some positively charged particles in matter which repel the a particle strongly, causing deviation. Hence, at the center of an atom is a positively charged nucleus. As a very small number of a particles got deviated through large angles and retracted their path, the size of the nucleus must be very small compared to that of an atom. The nucleus must also be very heavy. Hence, center of an atom is a massive nucleus.
Okay, so here we got the first point. The majority of the space occupied by the matter is vacuum. That means inside the atom, the space available, the most of the space are empty. Okay, that means the electrons, protons, and the neutrons staying in the atom, they are covering very less space. Okay, the other space is empty. They are very small. It's because they are very small in comparison to the size of the atom, and their mass is also very small. Okay. Then the second finding is, so this one you understand, right? That's the first observation was most of the alpha particle passed undeviated through the gold foil. So from this observation, we got this conclusion: the majority of the space occupied by the matter is vacuum or empty. You can say the maximum space of the atom is empty. Okay, is it clear, the first point, Aisha?
Yes.
Then the second observation is we got some of the alpha particles, they are deviating little bit. That means small angles. And from this observation, we can set up some argument that there must be some positively charged particles. Why they are saying so? Because alpha particles, do you know what is called alpha particle? Anyone, do you have idea what is called alpha particle?
No, what is an alpha particle?
Okay, alpha particle is the combination of two protons. In alpha particle, there are two protons, only two protons. That is called alpha particle. Is it clear now?
So when is an
Sir, two
alpha particle?
neutrons, no, sir?
No, only you see, we are talking about the charges, right? That's why
Yes,
we
sir.
are talking about the protons. So when they are going to there is neutron, but we are dealing with the charges now, right? Because they are causing deviation. Okay, two protons and neutrons are neutral. So two protons, when they are going very close to the nucleus of any atom, here we are dealing with the gold foil, so gold atom. Gold foil,
Sir,
it has its nucleus is big. Yeah, tell me.
sir, in the periodic table, all the elements in group 2 have alpha particles, right?
Again, please.
In the periodic table, all
Mhm.
the elements in group 2 have alpha particles, right?
In group two, all of them they have the nucleon number 4.
So they have two protons.
They all have
Aisha,
Huh?
again.
those group number is different from this.
Yeah. There
Group
because
gets the
elements.
electrons.
Yeah, elements. If you think of group two, there are some more. With atomic number is more,
All
right?
right.
There is not only two. They have helium. Okay, two protons, two neutrons. That one is helium.
What about deuterium?
Yeah, only helium. Alpha particle is sometimes also called helium nucleus. Got it?
Okay. Yep.
So as we are dealing with the charges. That's why I'm saying that there are two protons available in alpha particles, right? So as neutrons are neutral, already we understood it that neutron does not have any charge. That's why the repulsion comes is for uh, positive charges, right? Isn't it? So alpha particle is positively charged, and the nucleus is also positive charge. Clear? Is it
Yes,
clear?
sir.
So we are now getting the conclusion here. At the center of an atom is a positively charged nucleus.
Sir, neutron has no charge, right?
Yes. Neutron has no charge. Electrons have negative, protons have positive charges. Clear?
Yes, sir.
Okay. So you understood this one, the second one, the observation and the conclusion. Can you go to third one?
Yes, sir.
Yeah. Look, here we got some alpha particles, a very small number of alpha particles got deviated to large angles and retracted their path. The size of the nucleus must be very small. Already we got this idea that the most of the space is empty. That also mean that the nucleus is in a small space, very small space. And here what we are getting from the returning back of the alpha particles, some of the alpha particles are returning back. Why it is? Because the nucleus must also be very heavy. Hence, the center of an atom is a massive nucleus. Uh, just simply we are giving one example. Like you are having a very big sphere, right? Uh, and you have a small marble. You know that glass sphere, small, is the children are playing. The transparent one we say marble. Uh, do you
Uh-huh.
have, do you have any idea about that one?
Yes,
Hello.
sir.
Okay,
Yes,
that
sir.
one.
আমার কাছে ছিল
If
ছোটবেলায়।
if you if you uh, if you think this was simply that you are just throwing one marble at the big sphere, which one is in a stationary position, then what you will see after hitting the bigger one, the massive one, the marble will, if you are throwing the marble in a way that is sitting in the middle of the big sphere, then you will see it will return back, right? Isn't it?
Enough.
Isn't it? It will return back, and you will see that the bigger one, it will not move from its place. It will be staying in that place. Can you guess that one? Can you think that one?
This is heavier.
Yeah, it's heavier. So uh, the gold foil nucleus is a heavy nucleus. Okay, and in comparison to that one, we have the helium that's only small. That is 2 protons, 2 neutrons. So it's lighter, very lighter in comparison to the gold nucleus. It will return back. So from here we understood that the center of an atom is a massive nucleus. So you got these 3 points here.
Yes, sir.
Okay. Now after that we have some more discussions, basic discussions only. We have atomic number, mass number, nuclide notation. Already I told you what is called atomic number. Number of proton is uh, atomic number, right?
Yes.
And it is represented by Z. And number of neutrons is represented by N. Number of uh, nucleons or mass number, that is represented by A. So A equals N plus Z. Okay, got it? And
Yes, sir.
a nucleon, already I told you, is staying in the nucleus. That's why it is either a proton or a neutron. So neutron
Isn't
is
it both a proton and a neutron?
uh,
Because like nuclear numbers added.
yeah.
The
So
proton and neutron numbers are added.
if we add all the neutrons, all the protons, that one we say nucleon number, right?
Yes.
Total nucleon numbers or mass number. Okay, then I told you that the nuclide notation, that X here, X is here is showing one element like this one, carbon. We are showing here one element, carbon, and this element has number of protons 6, so it is atomic number Z. Then its nucleon numbers or mass number 12. 6 protons, 6 neutrons, total 12. Carbon 12 has 6 neutrons. So they are writing it how? Carbon 12 has 6 neutrons from this nuclide notation. If you have 6 protons and if you have the nucleon numbers 12, then you understand that 12 minus 6 is 6, right? That's giving you the neutron number. Now we are going for isotopes. The one Ziva told that number of protons are same, but the number of neutrons are different. Now we will apply the same idea here. Look, we have number of protons 6 and the nucleon number 14. So how many will be their neutrons? 14 minus 6, right? Is it?
8.
8. So
8
carbon 14 has 8 neutrons, and carbon 14 is an isotope of carbon, chemically the same, nuclearly different. Okay, chemically same. Why? Because if there are number of protons 6, then number of electrons are also 6, right? Hello.
Yes, sir.
And here also number of electrons 6. So chemical reactions, in chemical reactions there is nothing changed in the nucleus, only what is changed or shared, that is electron. From the outermost shells the electron is decreasing or increasing, or in some of the some of the places or some of the reactions they share the electrons, right? The outermost shell electrons are shared with each other, okay, in between two elements. So is it clear to you now about the isotopes? Hello? Hello?
Yes, sir.
So Aisha, Ziva, Liban,
Okay, sir.
yeah, you understood it, right? And
Yes, sir.
I'm uploading this recording, also uploading these notes in your Google Classroom, okay? By today, inshallah. Also the syllabus I will upload. Thank you so much for joining. We have around 1 minute. Okay. So you have any queries? Anything else to say? Anyone?
No.
No, sir. আজকে আরাম করে ঘুমান স্যার,
Wait,
আপনার
sir.
যদি ক্লাস না থাকে।
Yes, yes,
Sir,
yes, yes.
এটাই কি topic?
Yeah, this
Nuclear
one.
atom.
Yeah, end of topic. This is nuclear atom, a small topic.
এত তো কি?
Yes, actor topic. One topic is done. Another, there will be another topic. Topic 26. That is radioactivity. We
আমার like
discussed.
nuclear atom এত তো কি?
Yes, yes. Okay, Allah Hafiz. Thank you.
Sir.
বাই বাই স্যার। আসসালামু আলাইকুম স্যার।
Walaikum salam.